This is Anita Wood, and welcome to this topic snippet video, which discusses the specifics on creating a class in object-oriented programming. Remember the alarm clock we wanted to emulate in software? There are private attributes and public and private methods. This is a quoted object, meaning it's something we wish to emulate in software. We later learn more about the unquoted object, which will be instantiated from the class. How are the quoted objects emulated in software? First, the quoted object must be represented by a class in the code. A class is a general blueprint of the quoted object, like our alarm clock. A class is a collection of programming statements that specify the attributes and the methods that an object may have. Remember, a class is not an object, but a description of an object. When the program is running, it can use the class to create as many objects as needed. Here is the UML class diagram for our alarm clock. If you haven't watched the Introduction to UML Diagrams video earlier in the module, please do so. UML diagrams are essential to programming. They allow developers to communicate their ideas to each other. The top portion of the UML are attributes, and the bottom portion are the methods. The minus sign signifies private, and the plus sign is for public. We're going to change from emulating an alarm clock to something simpler, like a rectangle. On the left is a representation of the rectangle object, which we need to emulate with our software. The right shows the UML diagram detailing the class rectangle. The attributes we will save are its length and width. We will use the method calculate area to determine the area for the rectangle. Quick reminder, the area of a rectangle is length times width. Notice the UML diagram. There are 4 more methods listed. 2 start with set and 2 start with get. These 4 methods are needed because we've hidden the data or attributes of the class from the outside world. When I'm saying outside world, what I mean is any code outside of this class, like the code in the main method. The setter methods are also called mutator methods because they mutate or change the values of these private attributes. Another name you might see used for the getter methods is accessor. They access the values from the private attributes. Each attribute has its own pair of setter and getter methods. The best practice for naming these methods is shown in the UML. After the word set or get, you concatenate the method name with the name of the attribute. Also, the first letter of the attribute is capitalized. This practice makes it very easy for developers using the class or any other class to automatically know how to set and get values of the class's attributes. Here's the pseudocode that defines the rectangle class. Notice the setters and the getters. Each method deals specifically with a private attribute in the class. Look at the calculate age method just a bit closer. I said the area of a rectangle is calculated by multiplying the length by the width. The calculation in the method uses the getter for length and width. You might be wondering why these getters are called in the method calculate area. Because calculate area is really directly able to access these attributes. So here is another best practice. Anytime you're setting or getting an attribute, you should use the setters and getters, even if the method is inside the class. This emphasizes an important role of setters in particular. These methods allow strict control over the values that are allowed to be accepted. For instance, we do not want anyone to set the length or width for a rectangle to a negative number. The setter method can check for negative numbers prior to assigning the value to the private attribute. If a negative number is passed in, an error message will be returned and the attribute will not be set. The code above shows how this could be handled in pseudocode. Here's the Java code for the rectangle class. Look carefully at the structure because you'll be creating a class for your assignment. This code is also provided in the module below the video. Now, there is still a part of the code that we have not yet discussed called the constructor. Constructors are going to be discussed later in the module after we look at creating objects. So for now, just add the lines highlighted above to your code when you're creating a class definition. Now make sure you change rectangle to the name of the class that you're coding. This concludes the topic snippet that introduces how classes are created in OOP.